Good evening, everyone. Am I audible? Can you all hear me? Can somebody quickly confirm on the chat? Okay, thanks. Thanks, Yogesh. Thanks, Ranjit Kumar. So we will begin shortly. Okay, I'm just waiting for some more time for other people to join the meeting. We'll begin shortly on this series on foundational course on data science. Okay, so just have patience for maybe 5 more minutes. We'll start in 5 more minutes. Okay, let's wait for others to join. Okay, welcome everyone. Good evening. I'm Rohan. I am an AI researcher working at Indian Institute of Science, and I also teach at Innomatics Research Labs. So this is a brief course on foundation of data science. Okay. So our objective here is to sort of introduce you to this paradigm of data science, machine learning, sort of give you the whole jargon. Okay, maybe clarify the entire sort of topics that are involved in machine learning and data science so that you have a clear picture of what machine learning is, what are the opportunities in the field of machine learning and data science, and what are the sort of tools that you require to master the field of data science. Okay, so I mean, I guess all of you might have heard of machine learning or data science in the near past. So, I mean, you might have heard this buzzword that, I mean, there are a lot of jobs in this particular field. Okay, it's like growing in leaps and bounds these days. So the idea here is to sort of make you more informed on machine learning and data science, and so that you have sort of an idea that what are the kind of tools and what are the kind of skills that you require to secure a job in the field of data science and machine learning. So that's objective here. So I'd like you to make this entire talk as interactable as possible. So keep on asking questions. I understand that a lot of you might have a lot of questions about these topics. So it's fine if you keep on asking questions. That's the objective of this entire the course. Okay. So before we begin, do you have any quick questions about the structure of this class or anything? We'll have 5 sessions, okay, starting from today, and it will end on Friday. The sessions would be about an hour long, maybe hour and 15 minutes, okay, something like that. So we'll try to end by 9:10, 9:15 daily, okay, and we'll start precisely at 8, okay, every day. So please try to join the meeting by maybe 5 minutes to 8, okay, so that we can start by 8 and we'll end it by 9, 10, 9:15, something like that every day. Okay. Today's class would be very introductory in the sense that we'll introduce what machine learning is, okay, what are the different paradigms in machine learning, what are the kinds of tasks that you can solve using machine learning, okay, and also maybe briefly look at sort of the knowledge areas, okay, that you need to master machine learning and data science. So that's the objective. So before we begin, do you have any quick questions? By the way, I'm audible, right? I didn't confirm. So am I audible? Can you hear me properly? Do you need me to increase the volume, decrease it, anything? Okay. Is everything all right? Okay. So then let's proceed. Okay, so let me quickly, talk about Innomatics Research Lab. Okay, so our journey started in 2018. Okay, and we have trained. Okay, so there is a request, okay, from Innomatics Research Labs that everyone rename with your full name as a username in the Zoom. Okay, so I think some of you do not have your full name. So I mean, kindly everybody rename yourselves with your full name. Okay. Okay. So yeah, so we have trained more than 3,500 people. Okay. And we started our journey in 2018. We have trained over 150 plus batches. We have 14 batches currently running. Okay. So there are 75 plus trainers. Okay. And probably we'll talk about the structure of the classes that are being offered at Innomatic Research Lab at a later point. But yeah, so this is a brief journey of Innomatics Research Labs. And yeah, so some ground rules here that listen actively and attentively. Okay, you'll be on mute throughout the entire session. Okay, so if you want me to unmute yourself, if you want to ask a question, you can ask me to unmute you, but by default you would be on mute. Okay, so I mean, because there are a lot of people, it becomes a bit chaotic if everybody can unmute themselves at will. So I keep everybody on mute, but if you want to ask a question, either you can write it on the chat. Okay, I'll keep on monitoring the chat, or you can ask me to unmute you. Okay, then I'll unmute you and I'll let you ask a question. Okay, anything is fine with me. Okay, you can also raise your hand or just message me on the chat box. Okay, so today's agenda is like to discuss what is the need for data science. Okay, also discuss this difference between AI, ML, and DL. Okay, a lot of you might have heard of these terms. AI stands for artificial intelligence, ML stands for machine learning, and DL stands for deep learning. Okay, so what are the differences between these three different paradigms? Okay, so that's something which we're going to discuss. Okay, what are sort of the job opportunities, what are the market trends? Okay, and also what is the roadmap to become a data scientist? Okay, what are the sort of tools that you need to pick in the path so as to become a good data scientist? Okay, and we'll also sort of try to map what the data science curriculum that we have at Innomatics Research Lab, and how does it map it back to the sort of tools that you require to become a good data scientist. Okay, So that's the objective. And yeah, here, I mean, the structure of the classes that are being offered by Innomatics Research Lab is that the classes are always live. Okay, so you join the Zoom meetings and live sessions are provided. Okay, the sessions are also recorded for you, so that if you miss some of the lectures, okay, it's uploaded on a learning management system, LMS. Okay, and you have access, you have lifetime access to all the videos. Okay, so you can go back and watch the videos multiple times. We also provide you access to all the notes that we write on. Okay, and also all the notebooks. Okay, Python codes that we write together. Okay, we share all those Python notebooks with you also, so that you can go back and add on your codes on top of it. Okay, and each module is sort of delivered by experts. Okay, so we have different experts for, say, SQL module, Tableau module, machine learning module, statistics module. Okay, and you also get an IBM certification at the end of this entire course. Okay, and yeah, so 2 months of internship. Okay, makes you industry ready after the completion of the course. Okay, and yeah, so these are all sort of the ways of learning at Innomatics Research Labs. Okay, this is about the entire data science course that we have. Okay, the 6 month long data science course that we at Innomatics Research Lab offer. Okay, okay. So, what is the need for data science? Okay, let's first try and understand this. What is the need for data science? These days, I mean, so much data is available. Okay, because of this, huge boom in the field of in internet. Okay, you have so much data available that all companies are sort of trying to make use of data. Okay, to enhance their business. Okay, that's sort of the main reason behind this boom of data science and machine learning. Okay, in the recent years. Okay, say for example, I mean, a lot of you might have uh, bought Netflix subscription or Amazon Prime subscription, right? And every time you open Netflix, the Netflix account shows you some recommendations for movies or for some shows, right? We all of us might have seen this, right? So now, how does it recommend those movies or shows to you, right? And more often than not, they are quite good recommendations. Okay, the sort of series or movies that Netflix recommends to me, I go and watch those movies and series. Okay, that I mean, my interest does overlap. Okay, with the recommendations being shown to me by Netflix. Okay, but how does Netflix do it? Right, it has to somehow use the data. Okay, and give recommendations to you. Okay, this entire task, okay, has some machine learning component in the background. Okay, which tries to learn, which tries to sort of assess from your previous choices. Okay, what's your age? Okay, what's your gender? Based on various amounts of data that is accessible, okay, to the model, it tries to somehow recommend you the best sort of movie or TV series that you're most likely to watch. Okay, if you go ahead and watch that particular movie or that particular series, it receives something positive, right? That it has made a correct sort of prediction. Okay, that it has shown you the correct recommendation. If you do not press the play button on that particular movie, then it gives it a negative feedback. Okay, and somehow the model has to learn in this framework. Okay, I've given you one very specific use case, which is, I mean, used extensively in all of these recommendation systems. Okay, it's not just about recommending movies. Even if you open, say, Flipkart or Amazon, certain products are being recommended to you. Okay, or even if you see some ads, okay, what kinds of ads are sort of would seem appealing to you. Okay, so all of these tasks use machine learning and data science in the background. Okay, so the main reason behind using data science, or this huge boom in the field of data science, is the availability of data. Okay, the availability of a lot of public data. Okay, we'll discuss some more use cases as we move ahead in this entire course. Okay, but this was just one simple example. You have I mean, I gave this example for recommendation engine. Okay, you also have tasks from image analytics. Okay, say for example, I want to build a system which sort of recognizes somebody's handwriting, right? This would be useful, right? If somebody drops in a letter into the letter box, okay, and writes the pin code, handwritten pin code, okay, it might be a bit difficult for human beings to differentiate between the different digits, right? Okay, in that case, if we somehow let our computer differentiate between the different digits, okay, it might be, I mean, we could solve a very difficult task very efficiently. Okay, so you could imagine such tasks, okay, in images. Okay, or even in speech analytics. Okay, in speech, I mean, does anybody use Alexa? Has anybody used Alexa or Siri? I mean, do people know about Alexa and Siri? These are like, okay, so there are some yeses on the chat. Yeah. So, I mean, these are like systems which understands what you're speaking, right? You say, Alexa, play this music. Okay. Or Alexa, turn off the light. Okay. It understands your speech. Okay. And acts accordingly, right? And these systems are very good. Okay. I think these days, Alexa also supports Hindi along with English, right? So all these systems have some machine learning component in the background. Okay, some machine learning or some data science component in the background. Okay, text analytics. I'll give some more examples from all of these fields. Okay, text analysis, recommendation engine. We talked about recommendation engine. Okay, optimization, predictive analysis. We'll talk about these things as we move ahead. Okay, but I just give you a few examples to motivate the entire field. Okay. And so now let's briefly discuss what is sort of the life cycle of any data science project. Okay. But before I move ahead, do you have any questions? If you have any questions, you can ask me to unmute you or you can write it on the chat. Okay. Feel free to ask as many questions as you want. Okay. The session is designed so that you ask questions so that you know more about machine learning and data science, and you can, sort of decide for yourself whether you want to jump into this field of data science and machine learning. Is it worth it or not? Okay, so I mean, the more questions you ask, okay, the better it is. Okay. Okay, so let's briefly discuss the life cycle of any data science project. What are the sort of intermediate steps, okay, that you will find in any sort of deployable data science project? So Andharya is asking important applications of data science. We'll cover a lot of important applications. Okay, I'll give you a list of important applications towards the end. Okay, towards the end of today's class. I spoke about a few, like for example, recommendation engines. Okay, these are like frequently used in the industry these days. Okay, when Amazon or Flipkart or Myntra or Netflix or Amazon Prime, this recommend you some product or some product to buy or some movies or TV series, they are using data science or machine learning in the background. Okay, I will give a great list of important applications of data science. Okay, and then you can sort of see for yourself if some of the applications that you are working on, can they be automated using machine learning or data science or not. Okay, so bear with me towards till the end of this entire today's class. Okay, I'll give some important applications towards the end. Okay. Okay, so the first step in any data science project is to collect the data. Okay, that's sort of the first step. Okay, in many of the situations, in real life situations, you might not even have the data. Okay, the first step is to somehow collect data. Okay, say for example, let's take an example of say machine translation, right? A lot of you might have used Google Translate, right? It's a machine translation model. Why machine? Because computer is a machine, right? A machine is translating a language for you. That's why it's called a machine translation engine. Okay. So say, for example, you want to translate English to Hindi. Okay. Then you need a lot of data, right? To make a model, okay, to sort of make it translate language from say English to Hindi, somehow the model has to see a lot of translations and learn from it, right? I mean, if I ask you to translate English to French, you won't be able to, right? I guess nobody here knows French, right? You won't be able to. For that, you have to learn French, right? And then you have to look at English sentences and their corresponding French translations to understand how this translation goes on, right? We as human beings also require data, right? In a similar way, a machine also needs data, right? So if you want your model to translate English to Hindi, somehow you have to collect data a data which has English sentences and their corresponding Hindi translations, and give it to the model, so that now the model looks at these translations and learns how to translate English sentences into Hindi sentences. Okay. Is this point clear? Why data is required? Because you can't do any, I mean, nobody can, right? Human beings also can't, right? To be able to do a task, you need data. Okay. Is this making sense to all? Or does anybody want me to repeat why data collection is an important step? Okay, that's the first step and the most crucial step. In many situations, you might not even have a well-structured data. So a lot of time is spent by data scientists to collect data. Okay, to collect data that you can use in your model. Okay. Say for example, if I ask you to say translate I don't know, Latin to Assamese. Okay. Now, Latin to Assamese, for that, what do you need? You need Latin sentences and their corresponding Assamese translations, right? Now, this is a very difficult data set, right? I mean, can you go and find me a data set where you have, sentences written in Latin and their corresponding Assamese translations, right? That's a difficult data set to find. Okay. So you might have such situations in real life also, that you might not have data. In those cases, you have to go and search for data. Okay. Look for it. Okay, that's the first process. Somehow collect data, okay, according to the business problem that you have in front of you. The next step is called exploratory data analysis. Okay, the next step is called exploratory data analysis. It's also shortened as EDA. Okay, EDA stands for exploratory data analysis. Here, what you do is you try to explore or understand your data. Okay. In many situations, before you start building a model, okay, which would say recommend movies to you, okay, or translate English to Hindi, right? Even before doing that, you have to explore the data set yourself. Okay, try and understand what the data set looks like. Okay, we'll probably try to do this. Okay, it's a very important step. Okay, it's a very important step, and a lot of time is actually spent by data scientists in just exploring the data. Okay, trying to understand how the data behaves. Okay, is there an input, is there an output? Okay, how does the input to output mapping look like? Okay, what kind of model can I fit here? Okay, you have to do a lot of exploration in this step. Okay, and possibly we'll try to do such exploration in one of the sessions. Okay, in this mini course. Okay, the third step is data pre-processing. Okay. So when you collect data, the data might not be in a very good shape. Okay. For example, I mean, you might have some of the values missing in your data set. Okay. In those cases, what do you do? Okay. You don't have, some of the values are missing in your data set. Okay. Or some of them are corrupted. Okay. Or even if you don't have missing values, or you do not have corrupted data, even then, say for example, let me take a concrete example, because it's easier to understand stuff when somebody takes concrete example. Say for example, I want to translate the word, say, play. Okay, now here the word play, the P here is in caps. By the way, if I write something, is it visible? Is the annotation visible to you? I just want to make sure if you can see this annotation play. Okay. So if I write capital P LAY, okay, versus I write small p LAY, okay, versus say I write capital P, capital A, capital A, capital Y, right? All these three words mean the same thing, right? They should be translated to the same word in Hindi. Okay. In this case, khel, okay, or khelna, something like that, right? But they have three different structures here, right? So somehow you have to change all your letters to maybe small case letters. Okay, here one of them is in uppercase, okay, capital letter. Okay, here all four letters are in caps, okay, in capitals. Okay, you have to change them into lower form. Okay, this is some data processing. Okay, you have to sit down and change them. Okay, so all of these different tasks are done in this data pre-processing part. Okay, there are a lot of other things that you need to do in data pre-processing. We'll discuss them. Okay, but I just gave you a trailer of sort of the things that you need to do in the data pre-processing part. Okay, we'll look at some more things in the future. Okay, then comes the model building part. Okay, this is where you build a model. Okay, a machine learning or a data science model which does the task for you, a recommendation engine, okay, or a translator, Google Translate. Okay, okay, then you have something called model selection and evaluation. I won't discuss this particular step in detail now. I will discuss about this later because this makes sense once we discuss model building. Okay, here what happens is you actually build multiple models. Okay, a priori you do not know which model is going to perform the best. Okay, so you say, for example, you build the 5 different models. Okay, and then somehow you evaluate these models. Okay, model selection and evaluation, you evaluate each of the models and select the one which is the best among them. Okay, and then finally you deploy the model. Okay, so if you have built the model, now finally you deploy the model. Okay, this is the general life cycle of any data science or machine learning project. Okay, these are sort of the steps that you need to follow. Okay, we'll probably have one use case where we will try to sort of do all of these different steps. Okay, so that you understand the significance, okay, and the complexity of each of these phases individually. Okay, do you have any questions at this point? If you have any questions, you can ask them on the chat. Also, is my pace fine with all of you, or do you want me to slow down a bit or maybe increase my pace a bit? Is everybody comfortable with the pace? Okay. 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 So then let's move to the next slide. Okay. So AI, ML, DL. Now let me do one thing. So I have some more slides, but I prefer to write a bit now. Okay, so I'll just switch to my tab. Okay, and I'll start writing, and we'll discuss some things, and then we'll come back to this particular slide and continue from here. Okay, so just give me a few seconds. I'll just switch to my iPad. Okay. Okay, so yeah. Can someone confirm if they can see the screen? Okay, thanks. Okay, okay. So then now let's start talking about. So I'll now write. Okay, and also this is sort of the way that we teach at Innomatics, that we usually all the stuff that we teach, we usually write them. Okay, and all the codes that we teach, again we live code them. Okay, along with the students. Okay, so you would participate while the instructor is coding. Okay, and also while the instructor is teaching, you can participate it. Okay, and the instructor writes it for you. Okay. Okay, so now let me just, yep. Okay, all good to go. So you might have heard of these three terms. Okay, AI, ML, and DL. Okay, so A AI, okay, versus ML versus DL. Okay, so first things first, what is AI? AI is artificial intelligence. Okay, ML stands for machine learning. Okay, and DL stands for deep learning. Okay, so I want to right away differentiate between these three things. Okay, for you. Okay, and the way I want to do it is to sort of make this Venn diagram. Okay, do people know about Venn diagrams? Something we might have learned when we were in high school? Right? Does anybody remember Venn diagrams? So let me use three colors: black, red, and uh, maybe green. Yeah. Right. Yeah. From set theory. Right. So let me mark all of them. So this is like AI. Okay. This is like ML, and this is like DL. Okay. And so do people remember about subset? Right. So can you tell me, is DL a subset of ML or ML a subset of DL? Can you tell me from this Venn diagram? Is DL a subset of ML or ML a subset of DL? DL is a subset of ML. Okay, right? So DL is a smaller set, right? Inside ML, right? Okay, so DL is a subset of ML, right? ML stands for machine learning. Okay, it's like a huge set. Okay, it's a way of solving a problem. Okay, now machine learning have special kinds of architectures. Okay, which are called deep learning based architectures. Okay, so all deep learning models are indeed machine learning models. Okay, that's how you should look at this. Okay, and all are subsets of AI. Okay, that's true. Okay, as Vikram is saying, all are subsets of AI. Okay, so I mean, AI at a very high level is sort of the ability of a machine to imitate intelligent human behavior. Okay, it's a huge line. Let me write it. Okay, so that you can look at it. So here AI is like a very general objective. Okay, it's a broad objective. Okay, where we want our machine to imitate human intelligence. Okay, so ability of a machine, and when I say machine, it could be a computer, an iPad, a mobile phone, a robot, a self-driving car, whatever. Okay, some machine. Okay, which is not a human being. Okay, ability of a machine to imitate human behavior. Okay, this is the general objective in AI. That's why it's called artificial intelligence. Okay, it's intelligence, but it's not human intelligence, so that's why it's artificial intelligence. Okay, fine. Any questions on AI? It's like a broad paradigm, okay, where you want your machine to behave intelligently. Okay, just imagine a robot. Okay, a robot has to move forward. Okay, open a door. Okay, maybe clean something, take decisions. Okay, or maybe a self-driving car. Okay, it has to learn to drive on a road. Okay, not run over pedestrians. Okay, learn to obey traffic rules, and so on and so forth. Okay, so it has to behave in an intelligent way. Okay, that's the general goal of AI. Okay, machine learning, as the name suggests, okay, here again the goal is to solve some AI problem. Okay, but there would be a learning mechanism. Okay, the system would learn. Okay, so there are non-learning based AI also. Okay, which we won't cover at all. Okay, so there are other models which behaves intelligently without any learning component. Okay, but in machine learning, somehow the model has to automatically learn and improve from experience. Okay, so let me write this. So application of AI, okay, that allows a model to learn and improve from experience. Okay, this is machine learning. Okay, so if you build a self-driving car, okay, and now if the self-driving car sort of drives in the road, okay, for say 2 hours versus it run or it drives on the road for say 6 months. Okay, you expect that the model which runs for 6 months, that has learned more, right? Because it has access to more experience, right? It's also true about human beings, right? It's also true about human beings. As and when we gain more and more experience, we become better at the task, right? Just take an example of, driving a car or maybe swimming, right? Initially we are bad at it, okay, or even say, learning subjects, okay, learning languages, learning maths, okay, mathematics. Initially we are pretty bad at the subject, right? But as we gain more and more experience, somehow we learn, okay, and become better at it, okay. That's sort of the model that machine learning systems use, okay. They learn from experience. That's why it's called machine learning, okay. And to emphasize that there are other models, non-machine learning based models also, okay, which behave intelligently, okay. So there are some models in this region also, okay, outside ML but inside AI. We won't touch those models at all, okay. And those models are, to be fair, I mean, those models are not so popularly used these days, okay. These days everybody uses machine learning based models, so we are also, sort of focusing only on machine learning based models, okay. Fine. Any questions? Any questions? Any comments? Okay, so I'm guessing everything is fine. Okay. Finally, deep learning. Okay, which I mean DL, which stands for deep learning. Here, again, these are machine learning systems. Okay, which use something called deep neural networks. Okay. Do people know about neural networks? Have you heard the term neural network, or have you heard the term neuron? Has anybody heard the term neuron? Anybody who took biology in high school? I didn't. I took computer science, so I'm not a biologist at all. Yeah, Vikram is saying it's brain. It's not the entire brain. I mean, the brain is composed of neurons. Okay, right. So let me try to draw a neuron. I've always been bad at biology, so let me just see if I can draw a neuron. As far as I remember, it looked something like this. Yeah, this is the best I can do to make you imagine a neuron. So yeah, this is what a neuron looks like. Okay, this is the structure of a neuron. Uh, Sai is asking neural network used in ML. Yeah, yeah, yeah. Neural network is used in machine learning. Okay, and these models are specifically called neural network models or artificial neural network models, and sometimes these are also called deep learning or deep neural networks. Okay, so neural networks are used in machine learning. Okay, so I mean, see, again, I mean, you can't use a neural network, okay, because I mean neurons are composed of carbon and whatnot, okay, hydrogen and carbon. So I mean what we use is sort of a model of the neural network. Okay, so our brain has a neural network, right, where multiple neurons are connected with one another and they share information with one another, right? So we sort of try to mimic that architecture into a computer. Okay, that's what a neural network is. Okay, I'll speak about this a bit more. Okay, so just give me 5 minutes, I'll speak about this a bit more. So this is what a neuron is. This is a typical one neuron. Okay, and your brain has about, I don't know, maybe 200 or 300 billion neurons. Okay, 200 300 billion neurons. Okay, and there are trillions of connections between neurons. Okay, this is one neuron. Okay, so this neuron would be connected with another neuron here. Okay, this would be connected with another neuron here. Okay, this would be connected with another neuron here. Okay, and so on. So these connections between neurons is what a neural network is. Okay, a neural network is a connection or a network between different neurons. Okay, so if I remember it correctly, this part of the neuron is called axon. Okay, uh, this part is called dendrites. Okay, and the connection, so the connection between this part and the next neuron. Okay, so this is like the next neuron. Okay, this connection is, I think, called a synapse. Okay, and so on. Okay, by the way, I mean, there was a huge debate whether, these two things, okay, the neurons, do they touch each other or not? Okay, for a long time. Okay, but finally, I think after the discovery of an electron microscope, we came to know that they actually do not touch each other. Okay, they just send some chemicals. Okay, some chemicals are secreted from here, they go and touch it here. Okay, and that sort of signals the next neuron. Okay, this is how neurons communicate with one another. Okay, so this is a neural network, and we try to mimic such an architecture. Okay, that is what gives rise to artificial neural network. Okay, so let me write it. We try to mimic such an architecture, okay, in a computer, and this gives rise to artificial neural networks. Okay, any questions until now? Let me draw a typical, I mean, you won't now you won't appreciate this diagram a lot, because I mean, there are some missing details. I'll try to fill in the details towards the end of this entire course. Okay, so maybe by Friday's class you'd be able to understand what I'm drawing. Okay, but let me just give you a brief, sort of an idea of what a neural network looks like. Okay, so let me just copy these. I think I have a question. What is need of neural networks? Yeah. So what is a need? Okay. The answer is they perform well. Okay. They perform very well. Okay. These, I mean, have you heard of these cars? I mean, these self-driving cars that Tesla produces. Has anybody heard of those cars? I hope everybody has heard of Tesla and Elon Musk, right? He has recently even bought Twitter. So yeah, so these cars that Tesla produces, they are based on neural networks. Okay, they are deep learning based models. Okay, so they are the model that they use, okay, to train to train the car, okay, to self drive. They are deep learning based models. Okay, so the short answer is they perform very well in practice. Okay, that's why such architectures are used. Okay, and it makes sense in a way. See, I mean, we human beings are very good at a lot of these tasks, right? We are good at translating languages, provided that you know the source language and the target language. We are good at recognizing people. Okay, we are good at recommending movies to our friends. Okay, we are good at driving cars. We are good at I don't know, predicting, or predicting something, okay, in the future, at least in the near future. Okay, or maybe differentiating between faces of different people. Okay, so because we are good, okay, and our head, our brain has this has this neural architecture, this neural network. So the hope is that if we sort of try to translate it into a machine, the machine should also behave good, right? The machine should also behave like us. That was sort of the objective behind looking at these artificial neural network models. Okay, and it turned out that they do indeed behave very well in practice. Okay, uh, so yeah, I can't see your whole name. Yeah, so Saumil is asking, so these circles you're drawing are also working on ML. Yeah. So let me just complete the diagram. So I was speaking while I was drawing. So yeah, so these circles are like neurons. Okay, so in brain you have one neuron, right? And then you have connections between neurons. Okay, so here in computer, when you're drawing an artificial neural network, right, these circles, okay, these are neurons. Okay, these represents neurons. Okay, and these connections that you see, right, so these connections, I mean, these lines, okay, these lines are the connections between this neuron and this neuron. What it means is that this neuron can transfer information to this neuron. Okay, and so on, and this neuron can transfer information to this neuron can transfer information to this neuron. Okay, and so on. Okay, this is how artificial neural network looks like. Okay, we'll try to see this model in somewhat more detail, okay, in one of the later classes, but let me just stop it here. This is an artificial neural network. Okay, and it is trying to mimic the neural network model that we have inside our brain. Okay, instead of these kinds of neurons, it puts one. I mean, these circles represents neurons. Okay, and these lines sort of represents connections between neurons. Okay, and information passes through, it's maybe the information starts here. Okay, it passes to this neuron. This neuron passes the information to the next neuron. Everybody tries to do something. Okay, some computation. Okay, and overall the model tries to behave the way it should behave. Okay, it tries to behave intelligently. Okay, is this making sense? I mean, a lot of these things are a bit vague because, I mean, we will try to go into the details, okay, later on. But I mean, in the first lecture, I can't be, extremely precise. All of you would, just leave the meeting. So I'm just giving a broad picture of everything. Okay, is this clear? Is this clear? And why deep? Okay, the last point is, okay, everything is fine. Artificial neural network, everything is fine. Why the word deep? Okay, deep means if it has many layers. Okay, so this architecture has one layer, two layer, three layer. Okay, only three layers. If you make a very deep network which has say 150, 200, okay, 500 layers, okay, then it's called a deep neural network, and that's why the name deep learning. Okay, so the deep here just represents that the model is very deep. It has many layers. Okay, that's it. Okay, is this fine? Let me again pause here. So is the difference between AI, ML, and DL clear to all of you? If somebody asks you to differentiate between the three, would you all be able to do this? Okay. Okay. So now then let's move ahead. Okay. Now let's go a bit more deep, okay, into the kinds of tasks that are there. Okay, I mean, we'll first try to broadly look at some of the example tasks. Okay, and then we will try to classify them. Okay, how does machine learning classify those tasks? Okay, so first we'll try to, this is where, I think somebody was asking me, I forgot who, somebody was asking me about, use cases or the I mean, the types of problems where we use machine learning. So I'll try to sort of give you a list of problems where you can use machine learning and data science. Okay, and AI. Okay, I'll also keep on asking you. So I mean, if you have any suggestions at any point, feel free to, provide those suggestions. Okay, so let me see. Just give me one moment. Okay, so maybe let me construct a table. So we'll just list down some of these tasks, and then we'll stop here for today. Okay, we'll rejoin tomorrow and go into much more details of all of these different tasks. Okay, so let me write broad areas where you can sort of use machine learning. Okay, so let me start by writing something, and we'll discuss all of these. Okay, so natural language processing. Okay, you don't need to be scared of these terms. The objective here is to introduce you to these terms. Okay, so that you can see for yourself if machine learning and data science is something that you want to jump into or not. Okay, then maybe let me write something about computer vision. Okay, these are sort of the general tasks or broad areas where you can use machine learning. Okay, then maybe in speech. Okay, and finally maybe decision making. Okay, we'll list down some of the examples from each of these broad areas. Okay, okay, so first, natural language processing. So what is a natural language? So I'm saying image processing. Also, you can directly message me, or you can, write it to the whole group. I encourage everybody to write it to the whole group so that everybody can, see the question and the suggestions also. Okay. In case I just forget to, repeat it. Okay. So when you're sending a message, just change to, and don't direct the message to me, but direct it to everyone. Okay, then everybody would be able to see your suggestions as well as your questions. Okay, so Swami is suggesting image processing. Yeah, so we'll talk about image processing. That would broadly come under computer vision. Okay, we'll talk about it, but let's first start with NLP, which stands for natural language processing. Does anybody know what I mean by natural language? What is unnatural language? What is natural language? Does anybody know, or would anybody like to guess what a natural language is? And if you guess it correctly, then you have to say what an unnatural language is. So maybe I think a lot of you might be from computer science background. So let me write two languages. Okay. Gayatri saying binary codes. Yogesh is saying a language with structure in it. These are good suggestions, but okay. So what is a language with no structure? Can you give me an example of a language which does not have a structure? So I'm saying when we use Alexa or Google Assistant. Okay, so you're saying that when Alexa, when I use Alexa or Google, that's like an unnatural language. When I speak to my friend, then it's like a natural language. Is that what you're saying? Let me give you two languages, okay? And you tell me which is natural language, which is unnatural language, okay? Say English, okay, and Java. Which do you think is a natural language, and which is unnatural language? Java, or Python. Have you heard of Java? Have you heard of Java? Have you heard of Python? Sai is saying natural language is Python. English is natural language. Okay. Natural is English. Yeah. So a lot of you are saying that English is a natural language. Okay. Yeah. So what do we mean by natural? Natural, for at least for us human beings, from our perspective, everything which has got to do with human beings is natural. Anything and everything which has got nothing to do with human beings, that's like unnatural or artificial. Okay. So here also English is a natural language. Okay. So when I say natural language, I'm talking about human languages. Okay. Because there are languages which are not natural languages. For example, computer languages like Java, Python, C#, C++, C, okay, COBOL, blah, blah, blah. Okay. There are a lot of computer languages. Okay. That's why I have to differentiate between computer languages and human spoken languages. Okay. So when I say natural language processing, what I mean is I want to do processing on languages spoken by human beings. Okay, English, Hindi, Tamil, Telugu, okay, French, German, okay, some of these languages. Okay. So now can you give me some tasks in this domain? Any task that you can think of, that you can imagine, okay, or something that you would like your computer to do for you, okay, which has got something to do with natural languages, okay, or human spoken languages. I think we already took one example. Okay, we already took one example. Can anybody remind me the example? Translate. Exactly, right? So that's one task we would like to do, right? Translate. Okay, this is also sometimes called language translation, okay, or machine translation. Okay, so machine translation. Again, why machine? Because the machine is translating the language, okay, not human translation. Okay, so translating English to Hindi, or English to French, or French to German. Okay, that's one task which falls under the category of natural language processing. Can you think of some other task or something that you would like your machine to do for you? Okay, which has got something to do with, natural language. Speech to text. Yeah, that's one good example. Okay, that's a very good example indeed. But let me put that in this field. Okay, so in the field for speech to text. Okay, I'll tell you why I've put it here. Okay, and I've not put it here. I'll tell you that later. Okay, when we move to speech, I'll tell you, okay, why I've put speech to text here. Okay. By the way, I hope everybody understands what a speech to text model would do. It will take speech. Okay. It will listen to my voice. Okay. And convert it into written text. Okay. That's what this model would do. Okay. But I've put it here. Okay. Not in the NLP column. Okay. I'll tell you why later. Any other tasks that you can think of? Sentiment analysis. Exactly. Right. This is something which a lot of these companies use, sentiment analysis. Okay, so Twitter would like to sort of analyze the sentiment in favor of Donald Trump versus the sentiment in favor of Joe Biden, right? That's a sentiment analysis task. Okay, so here the objective is to somehow read somebody's tweet, okay, or maybe somebody's movie review, okay, and somehow analyze whether the sentiment of that particular review or that particular tweet is that a negative sentiment or a positive sentiment. Okay, that's the task of sentiment analysis. Yeah, now I have a lot of other examples also. Yeah, so spam or not spam, exactly. Okay, spam detection. Okay, so spam detection, that's a very good example. Okay, it's something which your email client uses, right? Which your email client uses. What a spam detector does is to somehow read your email, the content of your email, and either to put it in your inbox or to send it to the spam folder. Okay, it's a decision making task. Okay, and here also you have to read and understand the language. Okay, does it come under lie detection? Lie detection. Okay, I have never thought of lie detection as a machine learning model, but that's an interesting example. Okay, I do not know of any available detectors, I mean lie detectors which uses machine learning. Okay, I'm not sure. Okay, but this is a very good example. Okay, I mean we can use machine learning models for lie detection also. That's a good example. Spam or not spam, fake news detection. Yeah, so fake news detection is also an example. Okay, smart assistant. Okay, like Alexa or Siri. Okay, these are like they have to understand languages. Okay, so let me write smart assistant. Okay, and many more, right? You can think of many more examples. Chatbots, exactly. Okay, chatbots. Okay, I mean smart assistants or chatbots are I mean somewhat similar, but let's write it. Okay, in any case, let's write it. So chatbots, yeah, so chatbots are also natural language processing units. Text prediction. So when you say text prediction, what do you want to predict? Okay, text prediction, for example, sentiment analysis is also okay, so I think what you mean by text prediction is like text completion. Is that correct? So let me write text completion. And so in text completion, what you do is, or what your model does is yeah. So Sandesh is talking about text completion, where I mean you've seen this. You've probably seen this when you open your Gmail or your Outlook and you start writing your email, right? Then I mean after you write a few words, the system already prompts you with the remaining part of the sentence, right? And you can press tab and then the entire sentence gets filled, right? That's text prediction. Okay, given on the current part of your sentence, it tries to predict the remaining part of the sentence. Okay, that's again a natural language processing task. Okay, so we can keep on going on and on, but let me stop here. Okay, and for this particular column. Okay, there are many more examples. Okay, in the field of natural language processing. Okay, but these are like some very good examples. So okay, so now let's move to computer vision. So can you think of some tasks in computer vision? So I mean I hope everybody knows what vision is, right? So vision is the act of seeing something, right? So you would want your computer or your machine, okay, it could be some other machine also, to see. Okay, so it should be a task related to seeing. Okay, vision to computers, yeah, so that's computer vision, right? So I want some more specific tasks. Okay, face detection. Okay, right, so face detection is one task. Face detection, right? And I think a lot of us use face detection in our mobiles these days, right? We can unlock our phones using face detection, right? OCR, image to text, yeah. So OCR, okay, optical character recognition, right? Where you sort of try to recognize a character, handwritten character. Okay, scanning code. Okay, so data visualization is like a bit generic. Okay, I want you to maybe think of some more, I mean somewhat more concrete example. Okay, AI photography. So what do you mean by AI photography? Again, it's it's a task. I agree that it's an AI task. Okay, but I mean, you have to be a bit more, specific about the task. Mobile camera. I mean, so there's no, yeah, self-driving cars do use a computer vision a lot. Okay, but it's one part of it. Okay, so let me write something more specific. Okay, object detection. Okay, this is something which is used inside self-driving cars. Okay, the self-driving car looks at the road, okay, and tries to detect different objects. Is there another car in front of it? Okay, is there a pedestrian? Okay, is there a traffic signal? It detects different kinds of objects, okay, by looking at the road. Okay, so that's like a more specific task in computer vision. Okay, task reminder, does it use images? I mean, does task reminder use images, or does it use vision? I can give another example. Have you heard of this image captioning? I hope everybody knows what caption is. Caption is like a sentence which describes. Okay, so here the task is that you are given an image. Okay, and somehow you have to generate a caption for the image. Okay, what is happening inside the image? Okay, a man throwing a frisbee in the park. Okay, if there is a man, okay, if there is a man, this is my man, okay, and he's throwing a frisbee in the park, then you should write here a man throwing a frisbee in park. Okay, that's like image captioning. They're putting a caption on an image. Okay, that's again a computer vision task. Okay, there are many more examples. Okay, again in this field also. Okay, we won't have time to see all of these examples, not at least today. We might look at some more topics or some more examples in tomorrow's session. Okay, let's move ahead. Next is speech. So in speech, speech to text. Okay, we wrote speech to text, or maybe speech recognition, where you want to recognize somebody's voice. Okay, so I mean, the phone should only unlock if it hears some a specific individual's voice. Okay, it should not unlock if it hears somebody else's voice. Okay, so here you want to recognize somebody's voice. Okay, in the first example, you want to convert speech to text. Okay, so now why did I put speech to text here and not here? Can anybody tell me this? Can you think? Okay, why did I put speech to text here and not here? Why not in natural language processing? I mean, to be fair, I mean, you can put it here also. Nobody would, I mean, nobody would object. Okay, but I'm specifically putting it separately because in speech to text, okay, I mean, you're not so much worried about the grammar or the rules or the meaning of words in the language. Okay, so I think it has both characteristics. Yeah, to some extent, both. I mean, both of them. It has both characteristics of speech as well as NLP. But still, I'm putting it in speech specifically because in these tasks, okay, there is a requirement of understanding the words. Okay, if you want to translate English words into Hindi, you have to understand, or by you, I mean the model. Okay, the machine has to understand the meaning of the word. Okay, if it wants to do sentiment analysis, okay, not good, okay, versus not bad, these are opposite sentiments. Not good is bad sentiment, negative sentiment. Okay, not bad is positive sentiment, right? Okay, so it has to understand the meaning of words. Okay, even in spam detection, smart assistant, text completion, in all of these situations, it has to understand the meaning and the rules of the language. Okay, in speech to text, okay, such understanding of meaning and rules is not required. Okay, you just have to listen at the frequency and convert it into text. That's it. Okay, so less sort of emphasis on understanding the language. Okay, more on the the frequency and I mean, somehow converting the frequency with which you're speaking and converting it into text. Okay, so less emphasis on the meaning of words in the language. Okay, that's why I just categorize it here. Okay, and finally we'll just complete this decision making. These are like very general tasks. Okay, for example, I mean, the most famous example would be robot manipulation. Just give me 1 minute. Let me open the chat on my laptop. Yeah. Okay. So in decision making, something like robot manipulation. Okay. Manipulation. Okay. Or even self-driving cars. Self-driving cars. Okay. I mean, it has many components. Okay, one of those components is object detection. Okay, but finally it has to make some decisions. Okay, when I say decision making in an optimal way. Okay, whether to move right or to move left. Okay, if there's a robot, whether to open the door or take a step back. Okay, or move to the left, move to the right. What is optimal? Okay, yeah, drone exactly. Okay, so drone movement. Okay, that's also like a decision making task. Okay, or uh, let me think, what else can we loan prediction. Loan prediction is not a necessarily decision making task. uh, Let me give you another somewhat similar example. Portfolio selection. Okay, I hope everybody knows what whether to give a loan or not. Yeah, so whether to give a loan or not, that's not like a yeah, you can see it in from the lens of decision making also, but traditionally it has not been seen as a decision making task. Okay, so I understand what you're saying, Chandu, but I'm just not writing it here because traditionally people don't write it as a decision making task. Okay, but what Somil is suggesting, stock trading. Okay, which I've written. Portfolio means stock. Okay, so portfolio or stock selection. Okay, this has traditionally been seen as a decision making task. Okay, where you're given at the beginning of the day, you have maybe 100 or 500 different stocks that you can whose shares you can purchase. Okay, and at the end of the day, maybe you can sell some of the shares. Okay, and your objective is to maximize your profit. Okay, so this is like a decision making task. Should I purchase 5 shares from the 10th stock? Okay, or 100 shares from the 12th stock, and so on. Okay, so you have to make those intelligent decisions. Okay, that's like a decision making task. Okay, or even play a game. Okay, play a game, right? When your computer plays a game against you, it's making decisions. Okay, it's making decisions. Okay, I hope everybody knows that the game of chess, okay, this was solved way back in 1987, I guess, if I'm not incorrect. It was solved in 1987, okay, by Gary Tesaro's model, which beat the then world chess champion. Okay, and maybe tomorrow I'll talk. I think I have an image. So has anybody heard of this game? I'll stop here. Okay, so I mean the class would just end in 2-3 minutes, and I'm just going to talk about a particular game. Has anybody heard of this game called Go? Has anybody heard? Okay, so Sandhya has heard of Go. Has anybody else heard of this game called Go? It's a Chinese game. I haven't played it because I don't have Chinese friends. But yeah, I have an image of it here. This is the game of Go. Okay, it has a board. Okay, this is the board, and there are two players opposing each other. Okay, one player who plays with black, other player who plays with white. Okay, and everybody, I mean both of the players place their coins in turn. Okay, and the objective is to somehow cover the entire board with their own color. Okay, so white would like to cover the entire board with whites, black would like to cover the entire board with blacks. Okay, and the rules of the game is something like, if somehow a white is surrounded by blacks, okay, then you can remove this white and put a black. Okay, that becomes, I mean that particular spot becomes yours. Okay, so if you can surround a white region, okay, if you can surround the white region completely with blacks, you can remove those coins and put your coins. Okay, this is the game of Go. And for a long time, computers were not able to beat human beings at this game. Okay, only in 2016 came a model called AlphaGo. Okay, which beat the then world champion in the game of Go. Okay, it was as recent as in 2016. Okay, and the framework which was used is called reinforcement learning. Okay, again, you might have heard of it. We'll slightly talk about this paradigm. Okay, it's a very interesting paradigm, reinforcement learning, in tomorrow's session. Okay, we'll just talk about it briefly. How does it, manage to do it? And this particular part, this decision making column, is usually tackled with reinforcement learning. Okay. For other parts, you have, different kinds of models. We'll talk about some of these models in tomorrow's class, but my objective today was to sort of introduce you to the basic terminologies in the field of machine learning, data science, AI. Okay, and discuss some of these different use cases. Okay, so tomorrow, starting from tomorrow, we'll try to go into somewhat more detail. Okay, try and understand how do these models solve these tasks. Okay, so but I mean, we won't be able to go into details of a lot of these things, because I mean, I guess a lot of you do not already have the sort of the prerequisites. Okay, for example, let me ask, how many of you know Python? How many of you know Python? If you know Python, just write yes. If you don't know Python, write no. Okay. Okay, so there are a lot of yeses, and there are some no's also, right? So that's why I mean, I can't give you huge Python codes. Okay, I'll probably try to run the codes for you and show you what happens. Okay, but I mean, I won't be able to go into the details of the Python code. Okay, because a lot of you do not know Python. Okay, and that's fair. I mean, I also didn't know Python before I started with machine learning and all. Okay, so but if you take the course, the 6 month long course on machine learning and deep learning, okay, then I mean, our first module is on Python. Okay, so our objective there is to bring everybody to the same level, with regards to Python, and thereafter we start with the machine learning modules and statistics and all of these things, so that you can understand all the codes. Okay, but now we would sort of try to I mean, I'll try to maybe run the code, show you the results. Okay, but I won't discuss the codes, okay, in detail. Our objective here would be sort of to try and understand how these things work. Okay, and not exactly what to write to make it work. Okay, Chandra Singh, which is best among R versus Python? My personal preference is Python. Okay, I mean, uh, and I also recommend, okay, that Python, so I think Python is more efficient. More importantly, Python has a lot more libraries. Okay, if you understand what I mean by library, then Okay, I mean, a lot of people contribute to Python. Okay, so there are a lot of inbuilt functions in Python which you won't have access to if you're using R. Okay, so that's why I mean, Python is more rich. Okay, it has more functions. You can do a lot of things with Python. Okay, which you can't do with R. Okay, so that's why my preference is Python, because it's a general purpose language. You can do data analysis with it. You can do hypothesis testing with it. You can build your models with it. Okay, you can do all the things using Python. Okay, one language, you can do everything. Okay, you can even build your backends and front ends with Python. Okay, so you can do a lot of things with Python. That's why it's better to stick with go with one language, Python, rather than learning different languages for different kinds of tasks. Okay, that's why my preference is Python, and that's the reason why we teach Python. Okay, we don't teach R in our modules. Okay, we just teach Python. Okay, and yeah, Python is very easy to learn. Okay, it's almost similar to writing something in English. Okay, most of the times what you think in your head, okay, you just translate it into the code. It's correct Python syntax. Okay, it's that simple. Okay, okay, so we'll stop here for today. We'll rejoin tomorrow and try to see these models in somewhat more detail. Okay, so I hope to see you all again in tomorrow's session. Okay, I hope you learned something fruitful in today's session. If you have any feedbacks, you can share the feedbacks with me. If you want to hang around, if you want to have a conversation, I have so I'm letting you unmute yourselves. So if you have any questions, if you want to chat, I'm still here for maybe 5-10 minutes more. Okay, so you can hang around and chat. If you have any questions, if you want to clarify something, you can stay, or else you can start leaving. Okay, so I won't cover anything more in today's session. If you need to leave, you can start leaving. If you want to hang around, talk about something, you can write it in the chat or unmute yourself and ask. Okay, also, if you have any feedbacks for me, please do share. Okay, okay, thank you all, and yeah, so I hope to see you all again in tomorrow's session. Okay. Okay, so I think there are no more questions. Okay, so then let's stop here for today. We'll again rejoin tomorrow at 8, and please try to join maybe 5 minutes before 8 so that we can start sharp at 8. Okay. All right. So see you all tomorrow. Bye bye.